Okay, so we're going to do question 3 now. And what we're being asked to do is find certain things in terms of P and Q given this information. Now, I just want to remind you of a couple of different things. So when I multiply things with the same base, remember we just add the powers together. Because what this is saying is that there are 2 m's here, right? Squared means times by itself. And there's 3 of them here, which is why altogether we say that there are 5 of them. So we're going to use this principle over here. So the first thing asks us to find 2 to the power of x plus y. So if we're being told that we need x plus y, these bases match. So what we're really being asked to do is multiply 2x and 2y, because that would give us this, right? These are the same thing. And if we know that 2x is p, and we know that 2 to the power of y is q, well, it's just pq, right? P times q. That's all we got to do. Now, the second one, we're kind of partway there already. We're being asked to find 2 to the power of x plus y, but we're adding a minus 2. So we're going to use this same idea. What this really means is 2 to the power of x times 2 to the power of y times 2 to the power of negative 2. So what we need to do is think about this. Now, I just want to remind you of something. So if I have x to the power of negative 3, remember negative powers mean it's in the wrong place. So I'm going to put it on the bottom of a fraction because it should be in the other place. If it's on the bottom and it's negative, it should be on the top, but it's not. So I'm going to put it on the bottom, make it positive. This is the same thing. So 2 to the power of negative 2 is actually saying 1 over 2 squared, which is 1/4, right? So really, this is P times Q times 1/4. So altogether, I have 1/4 PQ. Now, the other way you can write this, they're exactly the same thing, is PQ divided by 4. Both of these are the same thing. That should be a big Q, by the way. That's just my terrible writing. Let's try that again. PQ over 4. These are the same thing. Timesing by 1/4, dividing by 4, same thing. That seems like the most reasonable way to write it to me, but who cares? Whichever way you want is fine. Okay, that's part 2. Okay, I'm just going to erase this bit over here so I've got space for part 3. So now we're being asked for 2 to the power of 3x, which again is the same principle. So if we have 2 to the power, we have 2 to the power of 3x, we're really going to take this same idea, right? If we've got 3x, what we're really looking for is 2 to the power of x times 2 to the power of x. Stop doing that. Times 2 to the power of x, because x plus x plus x is 3x. So really, 2 to the power of x is p. So this is p times p times p. And what happens when you've got 3 p's together? Well, it's cubed, isn't it? So this is actually p cubed because p is 2 to the power of x. All right. The next bit we're going to do is part B, and that's a bit trickier. So let's get rid of all of this first. All right. So we're looking at 3b. We're given some new information. So I'm going to rewrite that p is 2 to the power of x and q is 2 to the power of y. All right, but now we're given more information about what they actually equal. So, whoops. P squared times Q is 16, according to this. Oh, why is that happening? All right, so, and then I'm going to write my other one over here. So we're also told that Q squared divided by P is 32. All right, so I'm going to use my rules to do this same thing. So remember we said before that m squared times m cubed is m to the power of 5. We multiply. Remember if I'm dividing, so let's say that I have, do n this time, n to the power of 5 divided by n squared. Remember we subtract them this time. So this is n to the power of 3. Because again, what this is really saying is you've got 5 n's and you're dividing by 2 n's. Now, anything divided by itself is 1, so these cancel out. So we're left with 3 n's, which is why this works. So what I'm going to do is I'm going to rewrite some of this stuff. So p squared, this is the same idea that we said before, is that this is actually 2 to the power of 2x, right? 2 to the power of x is p, but there's 2 of them, so, well, it's squared, so I'm squaring this. And then I'm multiplying that by q, which is 2 to the power of y, and that equals 16. But what I'm actually going to do is rewrite 16 as a 2 as well. 2 to the power of 4 is 16. So now I have an equation where all the bases are 2. Now, remember our rule, we add the powers together. Now, if I've got bases that match, all I'm interested in now is the top. So I can just say that 2x plus y must equal 4. If these two things have to equal each other, then this power must equal this power. So now I have one equation. I'm going to do the same thing with this. So q squared is 2 to the power of 2y. And then I'm dividing by p, which is 2 to the power of 2x. No, it's not. It's 2 to the power of x. And that equals 32. But again, I'm going to write that as a power of 2. That's 2 to the power of 5. Now, remember, according to our rule, we subtract our powers when our bases match. So this is 2 to the power of 2y minus x equals 2 to the power of 5. So I know that these powers must match if these two things are equal. So 2y minus x equals 5. Now I have two different equations. Now I can use simultaneous equations to solve this. Okay, let me just erase this because I need more room. So what I'm going to do now is solve simultaneous equations. I'm going to use the elimination method, but you could use either. So let's pick another color. So I have 2x plus y equals 4, and I have 2, or actually I'm going to rewrite this because that will make my life a bit easier. Then I'm going to say that I have negative x, oh, why does that keep happening? Negative x, come on, plus 2y equals 5. All I did was write those two things backwards so that my x's line up and my y's line up. Now, I need either my y's to match or my x's to match. I don't care which one. I'm going to double the second one because why not? It really doesn't matter. I'm going to make my x's match. So I leave equation 1, but I'm going to times the second one by 2 to make this 2. So then I have negative 2x plus 4y equals 10. Now, if I add these together, I'm going to get rid of this. So that disappears. This becomes 5y, and this becomes 14, and that is absolutely not what I got before. So what have I done wrong? 2x plus y equals 4, 2y minus x equals 5. Ah, that's not what I had before. Did I copy it down wrong? 2 to the power of, oh, I've got these two backwards, don't I? This is q squared. Oh, no, I don't. Q squared over p, or did I write them backwards? Q is 2 to the power of y. Nope. No, this is right. Okay, so then y is 14 over 5, which is awful. I totally agree. This is a terrible fraction. And then I'm going to do the same thing with this to get x. So I'm going to put this back into any of my equations. It doesn't matter. I'm going to put it back into the first one just because I can, and I've run out of room to do that. So 2x plus y, which is 14 over 5, equals 4. And then I'm going to do 2x equals 4 minus 14 over 5. So then that means x is 3/5. And you simplify all that out. So these are obviously horrifying fractions, but that doesn't make it not true. It just makes it really annoying.